Hello, everyone. This is Gary Mathis here, software engineer. I've written a lot of things in a lot of different languages, such as C, C++, PHP, JavaScript. Um, Written a lot of things, C Sharp, but I've been really interested in Rust for a long time, and I've just never spent the time to learn it. Um, haven't really had a project to learn it with. Most of my projects are using those other languages I just listed. Um, and I mean, even today at work, I still don't have a project for Rust. So I have a goal in life that eventually I want to build an operating system and have a fully functional UI and things like that on it. Um, Maybe a pipe dream, but hopefully one day I can actually get started and build something that's, you know, worth building. Um, so what I'm doing here is I've got a little bit of time where um, in my mornings where I don't I'm not necessarily going to work and I'm working from home all the way up until the time that my job starts, which is roughly 9 o'clock, 9:30 in the morning, depending on the day. Um, so I want to start utilizing this time to learn something new and um, document the learning experience. Um, Maybe you guys can find something useful of it. And um, at this point, what I've found is this roguelike tutorial. It's written in Rust, um, and hopefully it looks like it's going through the whole thing with how to build this thing. Um, so yeah, without further ado, I'm gonna be reading basically this document verbatim. Now, just a little heads up, I may skip over some words, I may fumble my sentences a little bit. This is my first time actually just reading something from a screen onto a YouTube video, so hopefully with time, looks like this is going to take a little bit of time, but hopefully with time, I get better at doing this and I can do more content like this later on. Um, Maybe there's other languages I want to pick up, maybe assembly and things like that later on that I find a tutorial like this and I just read it word for word. Now I've kind of skimmed through this a little bit already, this introduction and building for the web. I'm just going to read through it and I'm not actually going to run some of these commands um, because there's not really a project set up until we get into actually section one, which is actually section two. But anywho, um, so here's the introduction um, of this roguelike. And it says every year the fine fellows over at our roguelike dev, just subreddit here, ran a tutorial Tuesday series encouraging new programmers to join the ranks of roguelike developers. Most languages end up being represented, and this year, 2019, I decided that I'd use it as an excuse to learn Rust. Me too. I didn't really want to use libtcod, which is a Python library, the default engine, so I created my own RLTK. Um, my initial entry into the series isn't very good, but I learned from it, and you can find it here if you're curious. Yeah, it's just like GitHub uh, for the initial version one of this blog series or this tutorial series. Um, the series always points people towards an excellent series of tutorials using Python and libtcod. You can find it here. Section 1 of this tutorial mirrors the structure of that tutorial and tries to take you from zero, how I open a console and say hello Rust, to hero, equipping items, fighting foes in a multi-level dungeon and such. I'm hoping to continue to extend the series. I also really want to use an entity component system. Rust has an excellent one called Specs, so I went with it. And I've also used ECS based setups in previous games, so it felt natural for me to use it. It's also a cause for continual confusion on the subreddit, so hopefully this tutorial can shine some light on its benefits and why you might want to use one. I've had a blast writing this and hope to continue writing. Please feel free to contact me on Twitter if you have any questions, ideas for improvements, or things you'd like me to add. Also, sorry about all the patrons spam. Hope someone will find this sufficiently useful and feel like throwing me a coffee or two. Um, yeah, so that's his little introduction here. I'm actually going to put a link to this at the bottom of every one of my videos that I post. So hopefully you guys can find it and follow along or go and do it on your own. That's certainly what I'm going to do. Now, fair. I'm just a topic. I've actually downloaded Rust before and I've played around with Rust, but I haven't actually done anything useful in Rust before. So this will be my first time actually building an application in Rust. So I'm a little familiar, but not really. All right, so we're going to go into building for the web here. Again, looking at this, I kind of skimmed through it already. Um, I'm not going to run any of these commands yet. It won't be until we actually get into Hello Rust and all of that. So, WebAssembly is a cool system that allows you to run code compiled for non-web based languages and run them in the browser. It comes with a few limitations. Your sandbox, so you can't access much in the way of files on the user's computer. I wonder if this is kind of similar to how you're sandboxing, say, a Docker environment. It'd be interesting to find out. Threads work differently in WASM, so normal multi-threading code may not work without help. Okay. Your rendering backend is going to be OpenGL, at least until WebGL is finished. Okay. OpenGL, I've played around with it in Java before, so not a huge deal. I haven't written code to access files from the web, so you have to embed the resources. The tutorial chapters do this with various RLTK embed resource calls. At the very least, you will need to include bytes or similar to store resources in the executables, or you can help me with a file reader. WASM is the tool used to make a playable chapter demos work in your browser. Okay. Building for the web. The process for making WASM version of your game is a little more involved than I'd like, but it works. I typically throw it into a batch file or shell script to automate the process. First of all, Rust needs to have a target installed to handle compilation to WebAssembly WASM. The target name is WASM32 unknown unknown. Assuming that you set up Rust with RustUp, you can install it by typing this. You also need a tool called WASM BindGen. It's a pretty impressive tool that can scan your WebAssembly and build bits and pieces that make the code run on the web. I use a command line version. There are ways to integrate it into your system. Hopefully that will be a topic of a future chapter. You can install the tool with Cargo. Okay. Step 1, compile the program for WASM. I recommend performing a release build for WASM. The debug versions can be huge and nobody wants to wait for an enormous program to download. Navigate to the root of your project and type cargo build release. Okay, so that's your build command. The first time you do this, it will take a while. It has to compile all the libraries you're using for WebAssembly. This creates files target WASM32 unknown release folder. There will be several folders of build information and similar, and you want important files, your project.d debug information, the actual WASM target. Replace your project for the name of your project. Okay, that's fine. Determine where to put the files. For the sake of simplicity, I'm going to use a target folder named WASM. You can use whatever you like, but you'll need to change the names of the rest of the instructions. Create a folder inside of your project root, for example, make directory WASM. Okay. Step 3, assemble web files. Now you need a WASM BindGen to build the web infrastructure required to integrate with the browser. So you run this command. If you look inside of the WASM folder, you'll see two files, your project.ts or JS JavaScript bindings for your project in your project BG WASM, a modified version of WASM output including the bindings required by the JavaScript file. I typically rename files to myblob.js and myblobBG.wasm. You don't have to do that, but it lets me use the same template HTML every time. Okay. Step 4: create some boilerplate HTML. In your WASM folder, you need to make an HTML page to host a launch application. I use the same boilerplate each time. This is what she looks like. And then step 5: you need to host it. You can't run WASM from a local file storage, presumably for security reasons. You need to put it into a web server and run it from there. If you have web hosting, copy your WASM folder to wherever you want, and then open your web server URL in a browser, and your game runs. If you don't have web hosting, you need to install a local web server and serve it from there. Okay, so we'll probably accomplish this with a Docker Compose file. Just saying, it makes it really easy. Um, so actually, now let's go ahead and get into the nooks and crannies of this thing. We've got kind of the pretext of this out of the way, and we'll probably refer back to this section 1 here um, for setup, getting it all working. So section 1, hello Rust. Um, Says, let's see here, why Rust? Rust first appeared in 2010, but has only relatively recently hit stable status. That is, code you write is pretty unlikely to stop working when the language changes now. Development is very much ongoing, with whole new sections of the language, such as asynchronous systems, still appearing stabilizing. This tutorial will stay away from the bleeding edge of development, and it should be stable. Rust was designed to be a better systems language. That's why I want to build an operating system in Rust later on. That is low level, like C++, but with far fewer opportunities to shoot yourself in the foot. A focus on avoiding many got-yous that make C++ development difficult. A massive focus on memory and thread safety is designed to be really difficult to write a program that corrupts its memory or suffers from race conditions. It's not impossible, but you'll have to try. It's rapidly gaining traction, with everyone from Mozilla to Microsoft showing interest, and an ever expanding number of tools being written in it. Rust is also designed to have a better ecosystem than C++. Cargo provides a complete package manager, so VC, PKG, Canon, etc. in C++ land, but Cargo is well integrated, a complete build system similar to CMake, Make, Meson, etc., but standardized. It doesn't run on as many platforms as C or C++, but the list is ever growing. I tried Rust after urging from friends, and found that while it doesn't replace C++ in my daily toolbox, there are many times that it really helped get a project out of the door. Its syntax takes a bit of getting used to. That's what I'm kind of scared. That's why it's a little bit different than a C-based language. Um, but it really does drop in nicely to existing infrastructure. All right, learning Rust. If you've used other programming languages, then there's a lot of help available. The Rust programming language book, the Learn Rust by Example, 24 Days of Rust, Rust Ownership Model, all of those should be fairly helpful. I might reference into those off camera, but just for the sake of this, I'm not going to open these at all. If you find that you need something that isn't there, it's quite likely that someone has written a crate or package um, in every other language, but Cargo deals with crates to help. Once you have a working environment, you can type cargo search, whatever your term is, to look for crates that help. You can also head to crates.io to see a full list of crates that are on offer. Yeah, that's a weird sentence. In Cargo, complete with documentation and examples. If you are completely new to programming, then a piece of bad news: Rust is a relatively young language So there isn't a lot of programming from scratch with Rust material out there yet. Yeah, yet. Rust is gaining traction fairly quickly. You may find it easier to start with a higher level language and then move down, closer to the metal, as it were, to Rust. The tutorial guides linked above should get you started if you decide to take the plunge, however. Getting Rust. On most platforms, Rust Up is enough to get a working Rust toolchain. On Windows, it's easy download, and you get a working Rust environment when it's done. On Unix-derived systems such as Linux and OS X, it provides some command line instructions to install the environment. Once installed, verify that it's working by typing cargo version on your command line. I think I already have it installed. We can try it. Yeah, I already have it installed. You should see something similar to 1.3. Yeah, the version will change over time. Yes, I have a newer version, so we're good. Getting comfortable with development environment. You may want to make a directory folder for your development work. I personally use, whatever that folder is. But that's a personal choice. It can really be anywhere you like. You'll also want a text editor. I'm a fan of VS Code. But you can use whatever you're comfortable with. Yeah, I'm probably not going to use VS Code. I'm probably going to try to use CLion here. And then I'm definitely not going to use that path. I've got a whole hard drive just for projects that gets backed up. So, but you can use whatever you're comfortable with. If you do use VS Code, I recommend the following extensions: Better Toml, CC++, yeah, and Rust RLS. Not the fastest, but thorough syntax highlighting. Okay. Once you've picked your environment, open up your editor, navigate to your new folder, VS Code file. Okay. So creating a project. Now that you're in the chosen folder, you want to open a terminal console window there, VS Code. Okay. Otherwise, open the command line as normal and cd into your folder. Okay. So I think I've already created a folder here. Let's actually just going to drop into my cool. So now I'm in my project drive and cargo init hello Rust. Okay. I'm gonna set up this project. That should be fine. I created it. Nice. That was quick. After a moment, a new folder appeared in your project title hello Rust. It will contain the following files and directories. Okay. So now I'm gonna open up CLion. I don't know if I need to uh, install any kind of Rust plugins. Maybe we'll. Oh, yes, I do. That shouldn't take long. Okay, we'll restart the IDE. All right, so we're gonna open, and I'm just gonna copy the path. Yes, we'll trust this. Uh, all right, now it's indexing. Got it. Using rest up. All right, while that's loading, quick Rust introduction, the anatomy of Hello World. The auto-generated main.rs looks like this. We can actually go and look. Yes, it looks exactly the same. If you used other program languages, this should look familiar, but syntax keywords are probably different. Rust standard out of the excuse me. Rust started out as a mashup between ML and C. with the intent to create a flexible systems language, meaning you can write bare metal code for your CPU without needing a virtual machine like Java or C Sharp do. Along the way, it inherited a lot of syntax from the two languages. I found the syntax looked awful for the first week of using it and came quite natural after that. Just like a human language, it takes a while for your brain to key into the syntax and layout. So hopefully that is true. That's what I'm so scared about Rust. The syntax can get kind of what looks to be bizarre to people that's worked in C-based languages. Um, so what does this all mean? FN is Rust keyword for function. In JavaScript or Java, it would read function main. In C, it would read void main, although main is meant to return an int in C. C sharp would be a static void main. Okay. Main is the name of the function. That's normal. In this case, the name is a special case. The operating system needs to know what to first what to run first when it loads the program into memory, and Rust will do the extra work to make main as the first function. You generally need a main function if you want your program to do anything, unless you are making a library or a collection of functions for other programs to use. Yeah, that's true. The open close parentheses is the function arguments parameters. In this case, there aren't any, so we just use the empty open and closing parentheses. Yeah, that's normal in C. Um, the open and close brackets indicates the start and end of a block. In this case, the block is the body of the function. Everything within the open and closing is content of the function. Instructions for it to run in turn. Blocks also denote scope. That's normal, actually. So anything you declare inside of a function uh, has its access limited to what that function to that function. In other words, if you make a variable inside of a function called cheese, it won't be visible from inside a function called mouse and vice versa. There are ways around this, and we'll cover them as we build our game. Println is a macro. Yeah, so this is kind of weird because yeah, other languages have macros, but they don't look the same. So println bang, right? It's a macro. Um, you can tell Rust macros because they have a bang after the other name. You can learn about macros here. For now, you'll just need to know that they're special functions that are parsed into other code during compilation. Printing to the screen can be quite complicated. You might want to say more than hello world, and the println macro covers a lot of formatting causes or cases. If you're familiar with C++, it's equivalent to standard format. Most languages have their own string formatting system since programmers tend to output a lot of text. The final closing bracket closes the block started in 4. So, yep. Go ahead and type cargo run. After some compilation, everything is working, and you'll be greeted with hello world in your terminal. I am just going to, can I add a run configuration here? That would be awesome. We'll use cargo command run factory. Okay. And we're going to try to go ahead and run this. Yep, there we go. Cool. Cargo run. There we go. Hello world. Yep, that's true. Cargo is quite the tool. You can learn a bit about it from the Rust book and everything about the cargo book if you're interested. Okay, there's links there. I'll look at that off camera. But yeah, you'll be interacting with cargo a lot while you work in Rust. If you initialize your program with cargo in it, the program is a cargo crate, compiling, testing, running, updating, dash cargo. Cargo can help with all of it. It even sets up a Git repository by default. Nice. You may find the following cargo features handy. Cargo init creates a new project. That's what you use to make the Hello World program. If you really don't want to be using it. Oh, if you really don't want to be using Git, you can type cargo init vcs none project name. Cargo build downloads all dependencies for a project and compiles them, and then compiles your program. It doesn't actually run your program, but this is a good way to quickly find compile errors. Cargo update will fetch new versions of the crates that you listed in your cargo.toml file. See below. Cargo clean can be used to delete all of the intermediate work files for your project, freeing up a bunch of disk space. They will automatically download and recompile the next time you run or build your project. Occasionally, a cargo clean will can help when things aren't working properly, particularly IDE integration. Okay. Cargo verify project will tell you if your cargo settings are correct. Okay. Cargo install can be used to install programs via cargo. This is helpful when installing tools that you need. Cool, that's great. Cargo also supports extensions, that is, plugins that make it do even more. There are some that you may find particularly useful. Cargo can reformat all your source code to look like standard Rust. From the Rust manuals, you need to type rust up component add Rust format once to install the tool. After that is done, you can type cargo format your code at any time. If you'd like to work with the README book format used for this book, yeah, the source code of this book, Cargo can help with that too. Just once you need to install mdbook and add all the tools to your system. After that, mdbook build will build a book project. mdbook init will create a new one, and mdbook serve will give you a local web server to view your work. You can learn all about mdbook on their documentation page, and Cargo can also integrate with a linter called Clippy. Clippy is a little pedantic, just like his Microsoft Office namesake. Um, just the once run rust up component add Clippy, and now you can type cargo Clippy at any time to see suggestions what could be wrong with your code. I'm going to go ahead and add each one of those because they wouldn't be calling them out unless they were going to be using it. Okay. Starving. A minute, don't they? I'm actually having quite a bit of fun with this. This is all new to me. Can't wait till we actually get into writing some code though. It looks like we're not that far away though. All right, and now we'll go ahead and Rust format. Okay, yep, that's already there. Perfect. All right, making a new project. Let's modify our newly created Hello World project to make use of RLTK, the Roguelike toolkit. Set up cargo.toml. The auto-generated cargo file would look like this. All right, let's go take a look. It sure does somewhat look like that. It has dependencies, which is blank. So what we need to do is throw that dependency there. Go ahead and make sure that your name is correct. Next, we're going to use cargo.rltk, roguelike toolkit library. Rust makes this very easy. Adjust the dependencies section to look like this. We're telling it that if the package named RLTK is available in cargo, so we have to give it a version You can do a cargo search RLTK to see the latest version anytime, or go to the Create webpage. It's a good idea to occasionally run cargo to update this. So update the libraries by your program. So I'm going to run this. Actually, no, I'm gonna keep it the same version that they're using. Go ahead and replace the contents of source main.rs. So I'm going to try not to copy and paste with this very often. So we're going to jump over here to actually going to throw my IDE over on the right side. All right, so I'm not going to be trying to copy and pasting. I'm going to be trying to manually type things. Helps with the muscle memory. Helps with the mind to learn things. So it looks like they're going to be using a use statement here at the top, which I imagine that's kind of like the import or include statements in other languages. So use RLTK. Okay, game state. Okay. Struct state. I wonder if that struct is the same as, say, a C++ or C struct. That'll be interesting to find out. IMPL game state state. This is weird. This right here is very weird. FN tick. MUT self CTX. I imagine that stands for context. MUT RLTK. Okay, CTX. I imagine CLS is clear screen. Because if you look at a game loop, a redraw on the screen is sometimes referred to as a tick. But if you never clear the screens, what you'll have is this big layering effect, and that's just kind of a result of OpenGL, and that's what we're using here is OpenGL. So we have to clear the screen before we can actually put something on the screen. That way we don't get that layering effect. That's what I'm imagining this is doing. Okay, so we are writing some text to the screen, it looks like. And then we're going to go back up to that the main function. We're going to clear the print line out. And it looks like, I think this arrow means it's a return type. Not completely sure. So use RLTK, that's weird. RLTK builder. Can I move this up here? I think I can. I'm gonna try it. Again, just piddling around here. Simple 80 by 50, yeah. Dot with title. Dot build. Let GS equals state. That's weird too. RLTK main loop. All right, will this work? Interested. Compiling, compiling, compiling. RLTK. Oh, context. Yes. Forgot to pass the function parameters in. Okay, context. Okay. 80 by 50 title. Okay. What is this? What does that question mark mean? Select enum result found. This is the returns as a body. Oh, does that? Oh, that's gonna throw me off. All right, we got it running. So Rust has some kind of weird things with semicolons, and I've read about this in the past. That's why I immediately knew to look at that. Um, Plus, that's not here, right? Um, so when you define a return type in Rust, there is no return. Well, I guess there is a return keyword, but it's kind of automatically labeled a return if it's the last line, right? And that last line cannot have a semicolon. I think I can just as easily just type in return. It's just like any other language. We can give that a run, find out. Um, I That's nice that it is, and that's the way that I'm going to be doing this because this will throw me off. Um, so that's good to know. All right, let's move on. Now, create a new folder called resources. Our LTK needs a few files to run, and this is where you put them. Download resources.zip and unzip it to this folder. Okay. New resources. Don't know what these are. I'm gonna put them in there. I would like to know what these are. Can I? Yeah. Okay, okay, this is the OpenGL stuff. Okay. Surprised that wasn't bundled in his library though. But yeah, this is OpenGL. This is the what is the name of it? VSGL or something like that. It's OpenGL rendering language. It gets sent off to your graphics card to render everything. If I run with that now, nothing changes. It's the same. But I imagine that's because we're not using it yet. All right, so download resources.zip and unzip it to this folder. Be careful to have resources/backing.fs. And not resources. Okay, okay. Save and go back to terminal, type cargo run, and you'll be greeted with a console window showing hello Rust. Alright, there's a lot of reading here. If you're new to Rust, you're probably wondering what exactly the hello Rust code does and why it's here. So we'll take a moment and go through it. And the first line is equivalent C++ include. Perfect. That's what I was thinking, and I was kind of correct when I was moving things around. It simply tells the compiler that we are going to require RLTK and game state from types from the namespace RLTK. You use to need to have an additional external crate line here, but the most recent versions of Rust can now figure that out for you. Um, that's nice. With struct state, we're creating a new structure. Structures are like records in Pascal or classes in many other languages. You can store a bunch of data inside of them, and you can also attach methods or functions to them. In this case, we don't actually need any data. We just need a place to attach code. If you'd like to learn more about structs, this is okay. So that is fundamentally different than C++. Um, Stored data in the C++ ones. You can, I guess, have function references within that, but you can't just attach functions to it like what we're doing here. So implementation for state. Okay. So with struct state, okay. We already read that. IMPL implementation. Um, Game state for state is quite a mouthful. So we're telling Rust that our state structure implements a trait game state. Traits are like interfaces or base classes in other languages. They set up a structure for you to implement with in your own code, which can interact. So, which can interact with the library that provides them. Okay. Without that library, you're having to know anything else. Without the library, having to know anything else about your code. In this case, game state is a trait provided by RLTK. Oh, okay. Oh, okay. So we're okay. RLTK requires that you have one. It uses it to call your program in each time. I thought this was a name. So we're basically saying, hey, let's implement the game state for this state struct. Okay. That's so weird. Okay. Function tick. I guess this is mutable self, and it's passed by reference. Context mutable RLTK is a function definition. We're inside of the trait implementation scope. So we're implementing the function for that trait. So it has to match the type required by the trait. Functions are basic building blocks for Rust. I recommend chapter on the topic. Okay, in this case, fn tick means make a function called tick. It's called tick because it ticks with each frame that is rendered. It's common game programming to refer to each iteration as a tick. It doesn't end with a type, so it's equivalent to void function of C. It doesn't return any data once it's called. The parameters also benefit from a little explanation. Okay. Mutable self means this function requires access to the parent structure and may change it. The MUT is short for mutable. That's what I thought. Meaning that it could change variables inside of the structure's state. Okay. You can also have functions in a structure that have just self, meaning we can see the contents of the structure, but we can't change it. If you omit the self altogether, the function can't see the structure at all, but it can be called as if the structure was a namespace. You see this a lot of functions called new that make a new copy of the structure for you. CTX mutable RLTK, it means pass in the variable called CTX. CTX is a abbreviation for context. That's what my guess was earlier. The colon indicates if we're specifying what type of variable it must be. Ampersand means pass a reference, which is a pointer to the existing copy of the variable. The variable isn't copied. You're working on the version that was passed in. If you make a change, you're changing the original. Mute once again indicates that this is mutable reference. You are allowed to make changes to the context. Finally, RLTK is the type of variable that you are receiving. In this case, it is a struct defined inside the RLTK library that provides various things that you could do to the screen. Okay. Context.clear CLS says Call the CLS function provided by the variable. CLS is a common abbreviation for clear the screen. We're telling our context that it should clear the virtual terminal. It's a good idea to do something at the beginning of a frame. To do this at the beginning of a frame unless you specifically don't want to. ctx.print 11 hello world is asking the context to print hello Rust world at the location 11. Now we get into function main. Every program has a main function that tells the operating system where to start the program. Use RLTK builder. Let context RLTK builder simple 50. Okay, it's an example of calling a function inside a struct, where the struct doesn't take a self function. In other languages, this would be called a constructor. For calling the function simple 80 by 50, which is a builder provided by RLTK to make a terminal 80 characters by 50 characters high. The window is called Roguelike tutorial. Okay. Let GS equal state stands for game state. Yeah. Is a example variable assignment. See Rust book. We're making a new variable called GS, short for game state, and setting it to be the copy of state struct that we defined above. So boom, boom. Yep. RLTK main loop context GS calls into the RLTK namespace, activating a function called main loop. It needs to be both context and game state we made earlier, so we pass those along with RLTK tries to take some of the complexity by running a GUI game application away and provides this wrapper. The function now takes over control of the program and will call your tick function. See above, every time the program ticks, that is, it finishes one cycle and moves to the next. This can happen 60 or more times per second. Hopefully that made some sense. That's a lot happening here. And just little 18 lines of code. Okay. Playing with the tutorials. You'd probably like to play with the tutorial code without having to type it all in. The good news is that it's up on GitHub for your pursuit. You'll need to have git installed rust up should have helped you with that. Choose where you would like to have the tutorials and open up a terminal. Okay, I'm not going to download them. I would like to manually type everything in. After a while, this will download the complete tutorial, including the source code for this book. It's laid out as follows. This isn't complete. What's here? Book folder contains the source code for this book. You can ignore it unless you feel like correcting any of my spelling. Each chapter's example code is contained in chapter XY name folders, chapter Hello Rust. The source folder, okay, resources, has the content of the zip file you downloaded for this example. All of the folder are pre-configured to use as cargo.toml setup and include all of the tutorials, workspace entries. They share dependency, so it won't eat your whole drive re-downloading it every time you use it. To run an example, open your terminal and cd where you put the tutorials, cd chapter 1 hello rust, and cargo run. If you're using VS Code, you can instead use file open folder, open the whole directory that you checked out using the inbuilt terminal. You can simply cd into each example and cargo run it. Okay, access and tutorial source code. You can get the source code for all the tutorials at GitHub. Updating the tutorial. I'm not going to read through all of this. I mean, this is just showing how to push updates into their repo, and I'm really not going to work with their repo. So, chapter 2, entities and components. Nice. Okay. So this is what we'll be going through tomorrow. Hopefully we can go through 2.1 and 2.2 tomorrow. These are both very, very long. My mouth is actually getting dry, so I may only cap these out to an hour. Um, so hopefully you guys like this video. I'm going to continue going down this rabbit hole here, and hopefully we'll see you guys on the other side. I'm gonna film another one tomorrow. Have a good day.